A line capital AB, 80 mm long, is inclined to HP at 30 degrees and inclined to VP at 45 degrees. Draw the front and top views of a line and determine their lengths. Also, measure the perpendicular distance of NB from both HP and VP. So, since we need to measure the perpendicular distance of NB from both HP and VP, so that should be the minimum distance from the perpendicular distance from both HP and also from VP. So, these two are the perpendicular distance. That is B2 dash to B2 and that is B1 dash to B1. So, this is the distances which we need to measure. But the end point of A is not mentioned that it is on both HP and VP. We have to decide only by considering this condition, that is the minimum distance what we need to achieve, because as we extend the distance with above HP and in front of VP, accordingly this distances will also going to be stretched. Because of that reason, so we have to take the point end A on both HP and VP. So now we are going to proceed with the problem. The line capital AB, means it is the true length. So it is 80 mm long, is inclined to HP at 30 degrees. So the inclination of the line with respect to HP is seen in VP. So with A dash as center, by using the draw a line which is inclined at 30 degrees to HP for 80 mm length, and then mark this point as B1 dash and draw the locus of B, that is the dashed out line, locus of B. And since this is the line which is in the true length, so obviously it is capital A and capital B1. Then the line is also inclined to VP at 45 degrees, which is 80 mm long. So from the same point, which is A, now in the top view, draw a line which is inclined at 45 degrees for a length of 80 mm and mark that point as B2 and also capital B2 because it is the true length. And now draw the dashed out line to give the locus. So that means the top view of the point B must lie on this locus and the front view of the line point B should lie on this locus. Now we know that this is the true length in HP. True length in HP, that means it is parallel to HP. And similarly, we know that this is the true length in VP, that means it is parallel to VP. Now we will start with the true length in VP. So we know that this is the true length in VP, that is because that is given in the problem. So we will mark this as AB1. So now, if this line has to be true length in VP, the line has to be parallel. That means when you look from the top view, NDA is in VP. Similarly, B1 should also be on VP only, so that line AB1 will be parallel to VP. Once the line AB1 is parallel to VP, so you are getting the true length in VP. That is this line. But B1 is not on VP, but B1 is in front of VP because due to the presence of this true length line which is inclined at 45 degrees of 65 mm length, 80 mm length. So you are going to get this point here. So this will going to be the locus of B. So in the top view, so the top view point B1 will not be on VP, it will be in front of VP by this distance. How to do that? With A as center, by taking the radius of AB1, you draw an arc such that it will going to cut the locus of B here. So this will going to be small b. Join A to B with a dark line. But by doing this, that means what we are doing is we are rotating this AB1, that is the line which is the true length, is rotated in space such that this point B will going to touches the locus of B in the top view. So that is what we have done here. So this will going to be the position of the, when you project this point, you are going to get this point small b here. So join these two. So because we have joined between capital A and capital B. This is the actual line, it is in space. This is the one which is there on HP, because when you look from the top view, the image will go to falls on HP. Now the same thing we will going to do it for VP now. That means I need to find out the front view now. So to do it for the front view, now we are going to consider the true length in HP. The true length in HP means it is parallel to HP. So it is all A is in HP, so B2 also on HP. So when you look from the front view, the image will go to falls on vertical plane. So A dash is on HP, so B2 dash is also on HP. So now A dash B2 dash is the line which is parallel to HP. So that is what? This is already parallel to HP. So now you are rotating this AB2 such that it will going to be touching the locus of B in the front view. So how? With A as center, by taking the radius of AB2, capital AB2, you rotate this B2 such that it will going to touch the locus of B in the front view. So you are going to get this point B. So join A to B with a dark line. So this will going to be the actual line which is in space. But when you are rotating this, what happens in the vertical plane? The image. So the image from A dash B2 dash with A dash as center, A dash B2 dash as a radius, it is drawing an arc so that it will going to cut the locus of B here. So that you will going to get this point as B dash. Then join A dash to B dash with a dark line. Then when you join B dash and B, both will going to lie on the same line. So then you measure the angle beta here and you measure the angle alpha here. And determine the distance, perpendicular distance of NB from both HP and VP. That means we need to determine B dash and B1 dash, B1 dash B1 and also B2 dash B2 is to be found out. So this is how we will going to analyze this problem in 3 dimensions. Now we will going to solve the same problem by using the sketchbook. First we will going to draw the XY line and mark this XY and VP HP as shown. So we have to consider a point. You have marked the point A dash and A because both NDA is in both HP and VP. So 80 mm long is inclined at 30 degrees to HP. Inclination is seen in VP. So with A dash as center, by using the protractor, you measure an angle of 30 degrees and draw an inclined line. Similarly, with A as center, by using the protractor, you measure an angle of 45 degrees and draw an inclined line in the top view because inclination with respect to VP is seen in HP. Since the true length is same in both in HP and VP, so by using the compass, you measure a distance of 80 mm. With A dash as center, cut an arc on this to get this point B1 dash. Similarly, with A as center, you cut an arc on this 45 degree line to get this point B2. Then join A dash B1 dash with little bit thicker than the projector line. Similarly, A to B2 with a little bit thicker than projector line. Then draw the dash dot line in the top view and also draw the dash dot line in the front view. 80 mm long 30 degrees is the actual true length, so you mark this as capital A and capital B, and here also capital A and capital B because both the length will going to be they remain the same. Now you write the locus of B in the top view and also locus of B in the front view, and here you write capital A and capital A. Now we have to start the solution. That means we need to find out the apparent length in the top view and also the inclination. To find out the apparent length in the top view and also its inclination, first we have to take the front view of true length. Because the front view is already the true length is available because it is given in the problem that AB of 80 mm long is inclined at 30 degrees to HP. So if this is the true length line in VP, obviously that line has to be parallel to VP. So that means NDA is in VP. So obviously the B1 should also must be on VP. Then only the line will be parallel to VP. That is what has been shown here. Okay. Then, so you draw a vertical projector from B1 dash to the XY line so that it will going to cut the XY line at this point. Then mark that point as B1 because this is the top view of the front view B1 dash. But actually the locus of B is in front of VP by this distance. So with A as center, by using the compass, you measure a radius of AB1 and draw an arc such that it will going to cut the locus of B at this point. So mark this point as small b. Then join A to B with a dark line. So measure this angle as beta. This is the apparent inclination in VP or with respect to VP. Now we are going to consider now in order to find out the front view and its inclination. So we have to take the top view true length. The top view true length is AB2. So you project AB2 to the front view. A is on HP, so you are going to get A dash, and B2 should also be on HP, then only the line will be parallel. So you project from B2 to the XY line so that A dash B2 dash is parallel to HP. That is what we have shown here, A dash B2 dash, which is parallel to HP when you look from the front view. Then actually in the front view, the locus of B will not be on HP, but it is above HP by this distance. So with A dash as center, by taking the radius of A dash B2 dash, you draw an arc by using the compass such that it will going to cut the locus of B in the front view at this point. Then mark that point as B dash and join A dash to B dash with a dark line. So this will go into the B front view. And denote this angle by alpha. Then since we have to measure the perpendicular distance of NB of both HP and VP, by using the scale you measure the distance from B1 to B1 dash, which is the vertical distance, which will be 40 mm, both in CAD as well as in the manual. And by using the scale you measure the distance from B2 to B2 dash, which will be 56.57 when you are doing it in computer. When you are doing it in manual, it will be 57 mm. This is how we can draw the solution. Now the same thing we have explained in step by step. So first we have considered the true length in VP. The true length in VP, obviously that line is parallel to VP, so we got this. But B1 is not in VP, but it is in front of VP by this distance. So we are rotating this AB1, that capital AB1, such that the B1 will going to touches the locus of B in the top view, so that the point will going to be in space. So you are going to get AB. But when you are doing that, the path traced by the on HP, this will be by rotation of the line AB1 such that B1 will going to cut the locus of B in the top view. So we are joining between A to B. So this will going to be the beta inclination. So that is what we have found out here also when you are doing it in manual. Also first we have considered the true length in the front view. So we have projected that such that this will be parallel. Then with AB1, A as center, AB1 as the radius, we draw an arc such that it will going to cut the locus of B in the top view, so that you will going to get this AB. So we got B1 dash and B1 in the front view. Now similarly, we are considering the top view now. So the top view true length parallel to HP. So we are rotating that capital AB2 such that this B2 will going to touches the locus of B in space. So you are going to get, it has been rotated till it reaches to the locus of B in the front view. So you are going to get this point. So you got capital AB in space. So when you are rotating this, obviously in vertical plane what happens, A dash B2 dash is the one which has been rotated such that this B2 dash will going to touches the locus of B in the front view and then join A dash B dash. So you are going to get this alpha inclination. That is what we have shown here. So we have taken the true length in HP. So we make it parallel to HP. So with A dash as center, A dash B2 dash as the radius, you draw an arc such that this will going to cut the locus of B in the front view. So you are going to get this A dash B dash. So then you measure B2 B2 dash. So this is the vertical distance. This will going to be the final solution what we want in the sketchbook. This is what I have written. So thank you.